Hello everyone, my name is Daniel Turner and welcome to my NC State Master of Geospatial Information Science and Technology capstone presentation, identifying change between NC Emergency Management Building Footprints and AI Extracted Building Footprints. My client is the North Carolina Center for Geographic Information and Analysis, who are the central JS office for North Carolina and runs several statewide programs. Relevant to this project is the NC Ortho Imagery Program, which captures 6-inch imagery of all of North Carolina in a 4-year cycle. They partnered with Amazon Web Services to extract building footprints using an AI machine learning model from their imagery that they collect. NC Emergency Management has a statewide building footprint layer, but it is created in 2010 from LiDAR and received minimal updates since then. So NC CGIA wanted an efficient way to identify differences between their AI extracted building footprints and the NC emergency management footprints. They want to assess the quality of their model and develop a plan to share the changes with NC emergency management. So I did this with 2 stages. First, the Python script to dynamically select the statewide footprints based on input data, identify emergency management footprints that do not overlap with AWS footprints and AWS footprints that do not overlap with EM footprints. And then we're going to identify AWS footprints that are a user-defined percentage larger than EM footprints. And then with that result, we're going to be putting that in an experience builder where multiple users will be able to QA, QC the results. So first we have some pre-processing. Mainly it's going to be performing a dissolve and adding some fields so that each building is only represented by one polygon. Pre-processing for the AWS output is there's a lot of stock geometry, and we're going to be dissolving those, repairing the geometry, and adding some fields. So first we're going to do in the Python script, we're going to be doing a site selection. So we're using imagery tiles to sort of select only the EM footprints that we're interested in. So we're not comparing the whole state to just the sample. Next, we do a change detection here with a select by location. We're selecting EM and AWS footprints that don't overlap each other. And we're also identifying, those footprints where the AWS footprint is significantly larger than the EM footprint. And we're exporting that to new field with some tracking. And as a note, EM footprints that are larger than AWS are not selected. And I did a sample area in Swannanoa, North Carolina, in the Hurricane Helene disaster area. It's about 32 square miles. And this imagery was captured by the NC Collaboratory. So this is how the output's going to look in ArcGIS Pro when it's symbolized. The saturated colors are unreviewed footprints. The muted colors have been reviewed. No hashing means an accepted, valid change. And with the hashing, that means it's not accepted. So some of the features of the experience builder are only 3 layers. The feature service of the results of the analysis, which I published to a standalone ArcGIS server in an enterprise geodatabase. We have our imagery tiles, which are more for reference, which I published to ArcGIS Online, and I'm streaming a post-Helene imagery image service from NC1Map. Created custom pop-ups using Arcade, which tell you how to score the footprints. And then users are going to be able to edit in the edit widget or in the table. And then you can query tiles or footprints themselves using the query widget. Here's just an overview of the app. So some final thoughts. This project successfully compared NC emergency management footprints to the new footprints derived by AI and deployed a web-based application where multiple credentialed users can QC the result. These products can be used by NC CGIA to check the quality of their AI model and potentially give the results to NC emergency management to aid in modernizing the statewide footprints. And going forward, the main question is who can QC the large amount of data that's going to be produced by this process, and how can we convert the QC process into the statewide footprint layer.